And I was able to calculate what the unit vector is, right? In the end, it came out to be negative 0.6400I plus 0.7680K. And it was unitless, right?
Yeah.
Inside of here is, do I have my R vector somewhere?
Yeah, it's at the top.
Yes. So this right here, does everybody agree that this is my R vector? Right? This is my R, C, D vector. It has a unit of, is it millimeters?
Yeah.
And this turns out to be millimeters. And they cancel, and that's how we get something unitless. So the unit vector of a line is equal to the R vector over, what should I put in the denominator? Andrew? My unit vector is equal to my R vector over, what's this value here representing?
Magnitude.
The magnitude of the R vector. This is important to remember. I know you know the difference between the two, but typically on the second exam, at least 2 people make a mistake and use E when they meant R and use R when they meant E. Okay, so just remember, remind yourself that always write down units. Because if you write down R and you put the units and you were supposed to have something unitless, it's going to be a trigger for you that you know you did something wrong. So the R represents what? The distances in the X, Y, and Z. And the magnitude means the total distance, which is the hypotenuse. And when we just divide the distance, the vector, by the total distance, we're getting a unit vector. Questions on this? Questions on unit vector and R? Okay, there's one other miscellaneous topic. The word resultant. Talk to the person next to you, and the 2 of you come up with a definition that you want to use for resultant. What is a resultant?
Addition of final.
Yeah, the rat.
What's the button?
Okay, we're up to Mark. So Mark, what did you and your partner decide is resultant?
We decided that it would be the sum of the moments.
Okay, so sum of the moments. Anything else? Is there something else too? And I heard somebody say, and Peter?
It's been the sum of the forces too.
And it's always been some of the forces as well. So what is it? It's really the net motion. A resultant is a net motion. And what are the 2 different types of motion? Rotational and translational. So from now on, if the textbook says, what is the resultant, what are you going to do? What mathematical calculations are you going to do? It says, what is the resultant of this problem? Cross product, if you try to find moments, right? But we don't have to do cross product, we can do right hand rule, right? So the method that we use doesn't matter, but if they want to know what is the resultant, we're going to sum up all the forces and we're going to sum up all the moments. So take your popsicle stick. Don't sharpen them. Okay, so I want you to push, watch what I'm doing, push this way and push this way, the same force, same force. If it's the same force, what's going to happen? What's the resultant? What's the resultant? Is it the rotation, is it translational or rotational? Rotational. If I apply the same force, it's going to stay in center position, right? This position is not changing. Now let's do this. What if I put two forces like this, and I apply the same force? What's the net motion?
Translational.
Translational. Okay, how about apply a larger force here and a smaller force here? What's happening? Translational and rotational. Let's do that one again. Apply a larger force on the left side and a smaller force on the right side. There's translational, but there's also rotational. Okay, so apply a force, you only have translational. I'm applying two forces and I'm only having translational. How about if I move the forces here and I apply the same force? I'm going to have rotation too, because this force is has a lever arm from the center. I'm going to have translational, but I'm also going to have rotation, because this is applying a larger force. What if I apply the same force in both directions? What am I going to get? Rotational only. And to transfer from today's topic to next topic, when you apply two forces, the same magnitude, opposite in direction, it's called a couple. So two forces, same magnitude, opposite direction, it's a couple. And what's the net result? What's the net resultant of a couple? Rotation. Is there any translational? No. So the net result of a couple, which is two forces acting in opposite directions with the same magnitude, the only resultant that occurs is a rotational motion. Okay? Okay. So on Thursday we'll do couples.